Hi guys, good day. I'm Archibald P. Claro, and today we're going to solve some problems involving right triangle trigonometry. So without further ado, let's start and solve some problems. Let's start with the item number 1. In item number 1, find the value of the 6 trigonometric functions of the angle theta in each figure. In figure A, we can observe that there is a missing length. Our angle of reference is angle theta. Since it is our angle of reference, the side opposite is 3 and the side adjacent is 4. So our missing length is our hypotenuse. To find the value of our hypotenuse, we will use the Pythagorean theorem. A squared plus b squared is equal to c squared. Now, let's go back to our figure. So, it is our angle of reference, angle theta, so our opposite, letter A, is 3, and our B, which is our adjacent, is 4, and our hypotenuse is C, which is our missing length. So, let's substitute the values to our formula. So, our A is 3, so A squared, so 3 squared, plus 4, 4 squared is equal to C squared. Law of exponent, so 3 times 3 is equal to 9, plus 4 to the power of 2, or 4 times 4 is equal to 16, to c squared. 9 plus 16 is equal to 25, is equal to c squared. Since it has squared, we need to square root both sides. So square root of 25 is 5, and square root of c squared is c. This is now our hypotenuse. Now, since we already found the lengths of each side, we can now find the value of the 6 trigonometric functions. So let's start with sine theta. Sine theta is equal to our opposite over hypotenuse. Sine theta, substitute. What is our opposite is 3, and our over our hypotenuse is 5. So we have sine theta is equal to 3 over 5. Next we have um, cosine theta. So to find cosine theta is equal to our adjacent over hypotenuse. So cosine theta is equal to the value of our adjacent is 4 and our hypotenuse is 5. So cosine theta is equal to 4 over 5. Next is our tangent, tan theta. So tan theta is equal to um, opposite over adjacent. So tan theta, substitute, or our opposite is 3 and our adjacent is 4. So our tangent theta is 3 over 4. Next, we will find the value of cosecant. Cosecant theta. To find the value of cosecant theta is equal to hypotenuse over opposite. So cosecant theta is equal to 5. The value of our hypotenuse is 5. Value of our opposite is 3. So cosecant theta is equal to 5 over 3. Next is our secant. Secant theta. To find secant theta, we have secant theta is equal to hypotenuse over adjacent. Secant theta is equal to the value of our hypotenuse, 5, and our adjacent is 4. So second theta is equal to 5 over 4. Next is our cotangent. Cotangent theta. To find cotangent theta is equal to adjacent over opposite. So cotangent theta is equal to our adjacent is 4, our opposite is 3. So this is now our cotangent theta is equal to 4 over 3. Now, we finally found the value of the 6 trigonometric functions of the angle theta. Now, let's try another problem. I have here a figure B. So, as you can observe, there is a missing length, and our angle of reference is angle theta. Since it is our angle of reference, the side opposite is 3, and the side adjacent is 3. And the missing length is our hypotenuse. Now again, to find the value of the hypotenuse, we will use the Pythagorean theorem. A squared plus b squared is equal to c squared. Now let's go back to our figure. This is our angle of reference. So our opposite side is 3, which is our A. And our opposite side is our adjacent side is our B. And this is our hypotenuse, C, the missing length. Now, let's substitute those values in our formula. So A is 3 squared plus 3, or B is 3 squared is equal to C squared. Law of exponent, 3 times 3 to the power of 2 is equal to 3 times 3 is equal to 9 plus 9 C squared. 9 plus 9 is equal to 18 is equal to C squared. Since it has squared, we need to square root both sides. So square root of 18, square root of 18 equal to 9 times square root of 2. So 3 square root of 2 square root of C squared is equal to C. This is now our hypotenuse. So 3 square root of 2. Since we already found the lengths of our triangle, we can now find the 6 trigonometric functions, the value of the 6 trigonometric functions. Let's start with sine theta. So sine theta is equal to opposite over hypotenuse. So sine theta is equal to, our opposite is 3, and our hypotenuse is 3 square root of 2. Since it has square root at the denominator, we need to rationalize its denominator. So by multiplying square root of 2 over square root of 2. So 3 square root of 2 is equal to 3 times square root of 2 is equal to 3 square root of 2 over 3 square root of 2 times square root of 2 is equal to square root of 4. So square root of 4 is 2. So 3 times 2. So 3 square root of 2, 3 times 2 is equal to 6. Simplify, we have square root of 2 over 2. This is now our sine theta. Sine theta is equal to square root of 2 over 2. Now, let's proceed to find the value of cosine theta. To find the value of cosine theta, cosine theta is equal to adjacent over hypotenuse. Cosine theta is equal to the value of our adjacent is 3, hypotenuse is 3 root of 2. Now, we need to rationalize the denominator. So 3 times square root of 2 is equal to 3 square root of 2. 3 Square root of 2 times square root of 2 is equal to square root of 4. Square root of 4 is 2. So 3 times 2 is 6. 3 square root of 2. Simplify. Square root of 2 over 2. So this is now our cosine theta. Cosine theta is equal to square root of 2 over 2. Now, let's find the value of tangent. Tangent theta is equal to tangent theta is equal to opposite over adjacent. So tan theta is equal to our opposite is 3, our adjacent is 3. So tangent theta is 1. Next, we will find the value of cosecant theta. So cosecant theta is equal to hypotenuse over opposite. So cosecant theta is equal to 3 square root of 2 and over 3 is equal to, simplify, we have square root of 2 over 1 is equal to square root of 2. So cosecant theta equal to square root of 2. This is now our secant. Next, let's proceed to find the value of secant. Secant theta. So secant theta is equal to hypotenuse over adjacent. So secant theta is equal to 3 square root of 2 over 3. Simplify, square root of 2 over 1, square root of 2. So secant theta is equal to square root of 2. The last one is the cotangent theta. Cot theta is equal to B over A, or adjacent over opposite. So cotangent theta is equal to 3 over 3 is equal to 1. So cotangent theta is equal to 1. Now, we finally found the value of the sixth trigonometric function of the angle theta in figure B. Now, let's proceed to item number 2. In item number 2, use the definition or identities to find exact value of each remaining 5 trigonometric functions of the acute angle theta. In this part, it's important to memorize those trigonometric identities like Pythagorean identities, quotient identities, and the reciprocal identities. Now, in our problem, letter A, sine theta is equal to square root of 2 over 2. Based on our given, we can find the value of um, cosecant theta and the cosine theta. How? First, we will find the um, cosecant theta by using reciprocal identities. So, cosecant theta is equal to 1 over sine theta. Now, you just substitute the value of sine theta. Square root of 2 over 2. Next, cosecant theta is equal to, when we divide fractions, we will multiply the we will multiply by the reciprocal of the second fraction. So 2 over square root of 2 is equal to 1 times 2 is equal to 2, and 1 times square root of 2 is square root of 2. Since it has square root in the denominator, we need to rationalize it. So we will multiply by square root of 2 over square root of 2. So 2 times square root of 2 is equal to 2 square root of 2. Square root of 2 times square root of 2 is equal to square root of 4. Square root of 4 is equal to 2. Simplify, we have square root of 2 over 1 is equal to square root of 2. So our cosecant theta is equal to square root of 2. This is now our cosecant theta. Next, we will find the value of cosine by using cosine theta by using Pythagorean identities. Now, the formula that we will going to use is the sine squared theta plus cos squared theta is equal to 1. Now, we will just substitute the value of sine theta. So sine squared theta or sine theta is equal to square root of 2 over 2. Since it is sine squared, so we will squared the square root of 2 over 2 plus bring down cos squared theta is equal to 1. Now, square root of 2 over 2 to the power of 2 is equal to um, square root of 4 over 4 plus cosine theta is equal to 1. Square root of 4 is 2 and square root and so 2 over 4. Simplify, we have 1 half plus cos squared theta is equal to 1. Now, after this, we will add both sides a negative 1 half. We will add both sides by negative 1 half so that we'll cancel this one. So, cosine squared theta is equal to 1 minus 1 over 2. So, cos squared theta is equal to 1 minus 1 half is equal to 1 half. Since it has squared, we need to square root both sides. So, cos theta is equal to 1 half. So, um, wait, of 1 half equal to square root of 1, square root of 2, rationalize square root of 2, square root of 2, we have 2, square root of 2 over 2. So, square root of 1 half is equal to square root of 2 over 2. This is now our cosine theta. Cosine theta is equal to square root of 2 over 2. Now, since we have sine theta and cosine theta, we can now find the value of tan theta by using the quotient identities. Now, the formula of quotient identities, find the tangent theta is equal to sine theta over cos theta. Tan theta, substitute the value of sine theta is square root of 2 over 2 over cosine theta, we have square root of 2 over 2. So tan square theta, if we will divide both fraction, we will multiply by the reciprocal of the second fraction. So square root of 2 times 2 is equal to 2 square root of 2, and 2 times square root of 2 is 2 square root of 2. Simplify, we have square root of 2 over square root of 2. Rationalize, we have square root of 2 times square root of 2, we have square root of 4 over square root of, no, by 2, no, we have 2. Sorry, square root of 4 over square root of 4. We have 2 over 2 is equal to 1. So tan theta is equal to 1. Next, we will find the value of cotangent theta. Since we have tan, we can now find the value of cotangent theta. So cotangent theta by using reciprocal identities. So cotangent theta is equal to 1 over tangent theta. Cotangent theta is equal to the value of tangent is 1. So 1 over 1. So cotangent theta is equal to 1. This is now our cotangent. Now, since we already have the cosine theta, we can find its reciprocal, which is secant. So secant theta by using reciprocal identities. So secant theta is equal to 1 over the cosine theta. So secant theta is equal to 1 over the value of cosine theta is square root of 2 over 2. So secant theta is equal to 1, and the reciprocal of square root of 2 over 2 is 2 over square root of 2. 2 square root of 2 rationalize square root of 2 over square root of 2. 2 square root of 2 over square root of 2 times square root of 2 square root of 4. So square root of 4 is 2. So simplify, we have 2 over 2 is equal to 1. So square root of 2 over 1 is equal to square root of 2. So our secant to square root of 2. This is now our secant theta. So we finally found the 5 remaining trigonometric function of the acute angle theta. Now let's proceed to another problem. Letter B. So tangent theta is equal to 1/2. Based on our given, we can find the value of secant and cotangent. But first, we will find the secant by using the Pythagorean identities. Pythagorean identities. Secant theta. So our formula that we are going to use is 1 plus tangent squared theta is equal to secant squared theta. By using this formula, let's substitute the value of tangent. So 1 plus tangent squared, we have 1/2 squared is equal to secant squared theta. So 1 plus 1 plus 1/2 squared is equal to 1 over 4 is equal to secant squared theta. So 1 plus 1/4 is equal to 5 over 4 is equal to secant squared theta. Since it has squared, we need to square root both sides. So secant squared by square root of secant squared is secant theta. Square root of 5 over 4, we have square root of 5 over square root of 4, 2. Square root of 5 over 2. So this is now our secant theta. Now next, we will find the reciprocal or the value of cotangent by using the reciprocal identities. So cotangent theta by using reciprocal identities. So cotangent theta is equal to 1 over tangent theta. Cotangent theta, 1, the value of tangent theta is equal to 1 half. So just substitute. So cotangent theta is equal to 1 times 2 over 1. 2 over 1 is equal to 2. So cotangent theta is equal to 2. Next, since we already have the second theta, we can find the cosine. So cosine theta by using the reciprocal identity. Reciprocal identity. So cosine theta is equal to 1 over secant theta. Just substitute. Cos theta is equal to 1 over square root of 5 over 2. So cosine theta is equal to 1. The reciprocal, we have 2 over square root of 5 is equal to 2 square root of 5. Rationalize square root of 5 over square root of 5. 2 times square root of 5, we have 2 square root of 5 over square root of 5 times square root of 5 is equal to square root of 25. Square root of 25 is 5. This is now our cosine theta is equal to 2 square root of 5 over 5. Next, since we have the cotangent, since we already have the cotangent, we can now find the cosecant theta. Cosecant theta by using the Pythagorean identities. So the formula that we're going to use is 1 plus cotangent squared theta is equal to cosecant tangent cosecant squared theta. Now 1 plus the value of cotangent, we have 2. So 2 squared is equal to cosecant squared theta. So 1 plus 2 times 2, 4 of cosecant theta. 5, 1 plus 4 is 5 cosecant theta. We need to square root both sides. So square root of 5 is equal to cosecant theta. This is now our cosecant theta. Now, the last one is the sine theta. Since we already have the cosecant theta, we can now find the value of sine theta by using reciprocal identities. So sine theta is equal to 1 over cosecant theta. So sine theta is equal to 1 over the value of cosecant, which is 45. Sine theta is equal to, we need to rationalize it. So square root of 5, 1 times square root of 5, square root of 5 times square root of 5 is equal to square root of 25. Square root of 25 is equal to 5. So sine theta is equal to square root of 5 over 5. This is now our sine theta. Finally, we found the value of the remaining trigonometric function of acute angle theta. Now, let's proceed to item number 3. In item number 3, given sine 30 degrees is equal to 1 half. Use trigonometric identities to find the exact value of cosecant pi over 6. Take note of this given. Now, to find the value of cosecant pi over 6, we will use the reciprocal identities. We will use the cosecant theta is equal to 1 sine theta. Now, let's just substitute. So cosecant, the value of theta, which is pi over 6 is equal to 1. Sine, the value of sine theta is sine 30 degrees. In radian, sine 30 degrees is pi over 6. Now, cosecant pi over 6 is equal to 1 over sine pi over 6 is equivalent to sine 30 degrees. Cosecant pi over 6 is equal to 1 over, since sine 30 degrees is equal to 1 half, so we will substitute. So 1 over 1 half. So cosecant theta over 6 is equal to 1 times the reciprocal. 2 over 1 is equal to 2 over 1 is equal to 2. So cosecant theta over 6 is equal to 2. This is now its exact value. Now, let's proceed to item number 4. In item number 4, simplify each expression for the given value of x. Assume the theta is acute. Now, in letter A, square root of 25 minus x squared if x is equal to 5 sine theta. To simplify this expression, the first thing that we need to do is to substitute x to our expression. So, square root of 25 minus x squared is equal to square root of 25 minus the value of x. We have 5 sine theta squared. Next, since it has exponent, we need to simplify. 25 minus 2 times 5, we have 25. And sine theta squared is equal to, sine theta to the power of 2 is sine squared theta. Next, square root of 25. Take note that sine squared theta is also the equivalent of 1 minus cos theta squared. In Pythagorean identities, sine squared theta plus cos squared theta is equal to 1. Add negative cos squared theta both sides. Squared theta. So cancel. So sine squared theta is equal to 1 minus cos squared theta. So sine squared theta is also equivalent to 1 minus cos squared theta. So we need to substitute sine squared theta to 1 minus cos squared theta. Square root of 25. As you can see, negative 25 can be distributed to the parentheses. So we will use distributive property. So negative 25 times 1 is equal to negative 25. Negative 25 times negative cos squared theta, we have positive 25 cos squared theta is equal to, we need to 25 minus 25 cancel. So the remaining is 25 square root of 25 cos squared theta. Square root of 25 is 5. And square root of cos squared theta is cos theta. Now this is now the simplified of this expression. So 25 minus x squared if x is equal to 5 sine theta is equal to 5 cos theta. Now let's proceed to a word problem. In item number 6, a tower that is 125 feet tall casts a shadow 172 feet long. Find the angle of elevation of the sun to the nearest degree. Now, to have a better understanding of this word problem, we will draw an illustration. Now, imagine that this is our tower. Our tower has a tall of 125 feet, cast a shadow 172 feet long. This is the shadow, 172 feet long. Since it is the shadow, imagine that this is the sun. Now, find the angle of elevation of the sun to the nearest degree. So, find the angle. So, this is now our angle of reference. So, our angle of reference. Now, this is now our opposite, uh, side opposite. This is now our side adjacent. Now, since our given is the adjacent and the what do you call this? And I no the opposite and the adjacent, we can use the um, formula, the formula of tan theta opposite over adjacent to find the angle of elevation. So tan theta is equal to 125 feet. The adjacent is 172 feet. Now, since our goal is to find the angle, so let's angle, so tan -1 times 125 feet over 172 feet. Theta, let's have our calculator. Oh, yun. Shift tan 125 feet divided by 172 is equal to 36 degree. This is now the angle of elevation. So we can conclude that the angle of elevation of the sun is 36 degree. That is now our final answer. Now let's proceed to our last problem. In item number 7, a plane rises from takeoff and flies at angle of 10 degrees with the horizontal runway. When it has rained 500 feet, find the distance to the nearest foot the plane has flown. To have a better understanding, let's draw an illustration. Imagine that this is our plane. Now, it has takeoff and flies at angle of 10 degrees. Is the horizontal runway. 10 degrees. When it has rained 500 feet. So imagine it's raining 500 feet. Find the distance to the nearest foot the plane has flown. So find the distance plane has flown. It means the distance. So the hypotenuse. So this is our angle of reference. This is now our um, side opposite, our adjacent. So the distance that we need to find is our hypotenuse. So since our given is opposite and our goal is to find the hypotenuse, or yes, the hypotenuse, we can use the sine theta is equal to opposite over hypotenuse. So let's substitute the value. So sine angle theta, which is 10 degrees, is equal to our opposite, which is 500 feet, over the distance, which is our hypotenuse, c. It's unknown. So since it is unknown and our goal is to find the hypotenuse, so we're going to multiply both sides by c for the hypotenuse. So cancel. So c times sine 10 degrees is equal to 500 feet. Now, again, our goal is to find the hypotenuse. So we need to divide it by sine 10 degrees, both sides, to cancel, so that we can now find the hypotenuse. So c is equal to, sa calculator, 500 feet over sine 10. We have 208.79 feet. This is now the distance that the plane has flown. So we can conclude that the distance that the plane has flown is 2,879 feet. This is now our answer. That's all. Thank you.